Would you like a hand microphone? Are you sure? Well, let me introduce you to Jose Maria Alonso, a completely unknown face to all of you in Spain. He holds a PhD from a local university. He's a chief data officer at Telefónica. And for you to understand what it means that he's in the C-suite in Telefónica, thanks to the fact that he's a member of the board, many of us will not be called nerds anymore. Okay? Chema is in that board, and that gives me the chance to sometimes attend board meetings. This is a really important message. I don't like Chema. You might like him, but what he's doing in the board for our community is really important. And that you need to take into your soul. Okay? So don't complain about your salaries. Think about the role that can be played by some of us. This guy with his funny hat is a member of the board, and he's a great help to everything we do. So Chema, thank you so much. I'm proud to have you here. You said you don't like me? Is that true? Come on. Okay, the projector is HDMI. Bear with me for a second. Okay, audio through HDMI as well. We get it through here. We plug it in there. Hello hackers, how are you doing? Is this pointing in the right direction? Are you sure? It's telling me something about quick time. This is here. Now, there we go, spectacular. Hackers, how are you doing? Those of you in the other rooms, I hope you can follow us. So this is the title of my presentation. It's got something in it that I really like. It is a talk that is a reflection of many years working hard on these topics. I think innovation and research and development are successful when you do things and people come along and criticize you and give you new ideas and give you food for thought. So this talk has nothing to do with hacking. It has to do with the opposite, with playing around to find out how to protect our Wi-Fi networks. This is a talk that started a track for me some 8 years ago, back in 2010. So I'll give you some background. I'll tell you about how we started working on this. A lot of people that started 8-10 years ago working with me on these ideas. Most of them are still working with me, so it's been really nice. It's been very beautiful to realize that we can still be together. So this is a lecture on wireless networks. This comic strip I love. Just read it yourself. We want the bit to build a nationwide wireless network. Bad news, we don't know how to build a nationwide wireless network. It's wireless. How hard could it be to not install wires? Well, wireless networks have always been related to attacks, have always related to limitations in security, like the problem we had last year, and attacks that are still taking place on every single protocol you can imagine. So the story I'm about to tell you starts in 2010, when we decided to take a look at potential ways to improve the security of people connecting to Wi-Fi networks from their endpoints. Back in 2010, we wrote this paper entitled Living in the Jungle, Legitimate Users and Legitimate Insecure Wireless Networks. As I say, we wrote this paper in 2010, Alejandro, Rodo, Jose Maria, me, as Roman said. At that time, I was getting my PhD, so I used that name. If you see Jose Maria Alonso, it's me, okay? Over and over again. And then Antonio Goodman, was also a Telefonica. We did something simple. We had a risk matrix to analyze the type of attacks that could take place in Wi-Fi networks. Well, you know all of these: traffic sniffing, session hijacking, access point spoofing, and in WPA1, WPA2. In WEP networks, the attacks always have to do with the number of packages that can be injected, but in the case of WPA and WPA2, we're talking basically about intercepting the authenticator package, doing forced root on passwords. So the length and the complexity of the password has something to do with the overall result. So that was the reason why we decided to write the paper. So we made a proposal through a tool, through a proof of concept. You know that we love proofs of concept with spaghetti code. We did something called Mummy. Believe it or not. What did Mummy do? 3 little things. One, you connected to a Wi-Fi network. You're connected to an open Wi-Fi network with WEP, high risk. If you're connected to a network which is WPA, we would analyze the complexity of a password and we would tell you about the overall level of risk. And then we would do some funny things like analyzing the neighbors that would connect to your own Wi-Fi network to analyze their behavior. If one of them was injecting packets or was doing spoofing, the Wi-Fi client would raise the level of risk and show an alert. So we basically changed the Wi-Fi client to make it more comprehensive. Things got much worse. Do you remember what happened when smartphones came along massively to users around the world? So the problem got worse. In fact, this is an article from 2011. I wrote this in Seguridad Apple. This is a blog. We used to write anonymously. It was all of us writing. And this had to do with the Wi-Fi client for iOS, connecting you automatically to the list of preferred Wi-Fi networks. The main problem here, this is, as I say, a paper from 2011. It cannot see the list of known networks. So you cannot eliminate them unless you are close to them. You cannot assign different levels of priority when connecting to different networks. And of course, protections have been eliminated on checking the SSID for the access point you might be connecting to. If you have the same name and the same structure for Wi-Fi protocols, it will connect automatically. This was done in smartphones because many of the infrastructure networks are installed in an unsuitable manner, and they have security problems. This was 2011. We kept working in 2012. We did JavaScript botnets, introducing a man in the middle with anonymous proxies on the internet and with access points as well. This was written in the book on hacking iOS. This chapter was written by Joseba, by the way. We would use a malicious access point with a rogue IP. The iPhone would connect. We would then inject the hooks in the phone calls to retrieve the passwords. Well, you know all about JavaScript botnets. And then in 2013, you remember Raúl Siles telling us about the preferred lists and the tools. For the first time ever, we had the tool to eliminate preferred networks without being close to those networks. We would need that to attack. Raúl needed that to defend. Well, that was it in 2012 and 2013. Talking about access points, still unresolved. Why still unresolved? Well, still unresolved even for environments which are much more common, like laptops. They've lowered the security level in Wi-Fi clients. So the crazy idea we came up with was, how about modifying the Wi-Fi client to make it connect to the access point if you're in the same location where you connected the first time? For a smartphone, this could be a good idea. For a And a conventional desktop operating system, that would get very complicated. This is 2011 again. Back then, it was the first time I started working with Mac OS. I saw that the security in Mac operating systems didn't do any checkups of access points. At that time, Windows did it. And Windows has gone the other way. Now, Windows doesn't do that checkup. They have eliminated the checks they did on SSIDs and access points. So for mobile phones, we started thinking about using the GPS unit, the embedded GPS unit. The first thing that came to our mind was this type of attack, as you see here. Support-defined radio attacks. And I brought an article, I brought a paper. I like this. This he would do with an iPhone in Madrid, with an SDR RTL attack, sending the iPhone to Paris. I'll play the music. Never mind. You see that the iPhone is in Madrid with a nice script. It is sent to Paris. Really cool. The video you can download completely. He did a really sophisticated, a very cool script. He would send the iPhone to Central Park, including all sorts of elements in the maps. Very amusing, actually. So, there's many ways to do this. There's many ways to geolocate smartphones. One of the things that we have attempted to show is making people aware of the importance of your location. If someone knows that you're in a certain spot at a certain time, they may know whether you're going to church, or whether you're a chronic patient going to hospital, or whether you've gone shopping and you're buying katanas, or you've gone to a sex shop, or you're attending a match. So advertising companies have been doing their best to try and get hold of data on your position without using the embedded GPS unit. There's lots of techniques that allow them to know where you are at any point in time. For example, your IP address is really funny. Once Steve Jobs passed away, his iPad was stolen. A thief took it from his home. He plugged it in a Wi-Fi network, connecting to Apple servers, and within minutes, he had the entire police department getting him arrested. There's many ways to be located. As you know, smartphones, well, we heard about that a long time ago. That goes for iOS and Android. They geolocate you through the locations of the SSIDs you're connecting to, so these companies know exactly where you are. And then there are some cool methods. PowerSpy. This uses machine learning. Many smartphones report on their battery status. You know, there are certain functions were eliminated to know about the battery consumption for any device, for any smartphone, for any laptop. So what they do with this methodology is you train a system using machine learning by selecting devices and moving them around a city to different locations to see what the discharging pattern for the battery is, and then you do predictive analytics. You give it a discharge pattern, and that gives us the most probable route for the user of that smartphone. And then, of course, there are ways to geolocate the user by using the telephony components. We have antennas in certain very specific locations, and we know what handsets are connected to the antennas and with what type of signal. In the case of the pattern that I have just mentioned, this is particularly relevant because our telephones adjust the strength of the signal based on the distance from the antenna, and we know at what distance, roughly, they may be. So there are ways to know where you are, even with your GPS unit disconnected or switched off. So that was the idea behind SSID pinning. Sergio de los Santos loves pinning. He wants to pin everything in the universe. So he said, how about SSID pinning? In order to know the Wi-Fi access point you're connecting to, we'll see what patterns were there when you first connected to that network. The first time we had access to the GPS unit. So let's give it 1 point in our ranking. We may know things like BSSID, deprecated by the way. And then another idea, which is quite funny, quite striking. Regardless of where you are, and regardless of what the war driving techniques are doing, since not all databases are public, they're in the hands of smartphone vendors. They have the full map of all Wi-Fi access points. We'll do something simpler. I'll just take a look at the Wi-Fi networks that are present in this room without caring about the GPS location, and let us establish a threshold in order to calculate how many Wi-Fi networks were present at the time of connection to give me an alert. So after putting together Mummy, we came up with Psycho Wi-Fi, the second tool. Again, another Wi-Fi client, just like Mummy, but using SSID pinning. Every time you connect to a Wi-Fi network, what do? Well, we look at the environment using GPS. We see what networks are present in that area, and then we create a pinned profile within the operating system for that Wi-Fi network you're connected to. And when it tries to connect automatically to that preferred network, you block it, we block it. So you don't have automated connections to the Wi-Fi networks in your preferred list. And that's how it works. I'll show you a very short video that explains the concept behind it. Here we have a Wi-Fi network which is not secure. We have created a rogue access point that has nothing to do with the previous profile. What the client does, Psycho Wi-Fi tells you, and it disconnects you from the network. As simple as that. You have this network in the list of preferred networks and you don't know about it. What the tool does is it blocks that network as soon as you try to connect to it and gives you an alert. It shows a warning message telling you about the differences between the initial network and the current network. And since this is a rogue AP and it's nearby, you can delete it. Beautiful, isn't it? This works also for Windows. In Windows it is slightly different. The basic operation is the same. It's still a Wi-Fi client, of course.
Pues utilizamos solo toda la parte.
And since we don't have the GPS location, before Windows would protect that, but in the latest versions, they've decided to make it more usable and less customizable.
Y cuando se intenta conectar, de nuevo, intenta conectarse la herramienta, como vamos a ver.
So the tool will disconnect you automatically because it doesn't meet the requirements as set in your pinning procedure. Simple. We are never in the trusted zone. It never connects automatically, which is what we want to achieve. Okay, we achieved that. So how about Windows 10? In Windows 10 we have the possibility to do max spoofing. That is a good option. On a regular basis, it changes the MAC for the client and replaces it with a virtual MAC so that you cannot be tracked in Wi-Fi network. This is a good thing, but it has to be enabled. People tend to forget that this has to be enabled, and in previous versions of the operating system it was not available. So in our tool we have MAC spoofing. As simple as that. We keep changing the MAC address. All the tools, all the proofs of concept that I'm showing you will be uploaded to the 11 Paths website so that you can see them. Okay, so here comes 2017 and crack comes along. Crack overrides everything. It allows us to do anything, carry out any type of attacks. And by the way, not simple to resolve. All systems based on pre-shared keys, on exchanging pre-shared keys, are involved. The only way is to set up SSL tunnels with a more corporate approach to avoid these attacks. But since this is based on reusing packets, it doesn't need too much time. So this is a logical flaw in the protocol, and it needs to be changed. And that's why we have seen the need to move to the new specifications for WPA3, which is the direction we are following. We'll see this shortly. We'll see the first implementations of that protocol shortly. Let us hope that happens quickly. And we move faster than we move from WPA to WPA2.
Well, when we take a look at the attacks that are made to the key, well, attacks can be classified in 4 different ways. So we have the online attack carried out through brute force, by using a high number of packets or sufficient time interval to make the attack. This is what we want with the web protocol, and then the crack type attack through logic bugs, and then we have offline through brute force through very many packets, or then brute force through one packet only, where we intercept the authentication packet, and once we have it, we could move on to our attack. Well, other than crack, all the attacks that are about attacking the key and that are not carried out through brute force or through time or through number of packets, there is a window of opportunity. They either require some time or they require a high number of packets. So what we thought about to kind of self-defend our environment was something crazy, and they say, oh, if instead of using a system with one key, why don't I change the key of my router every minute or every hour or every day? So doing something like that has the following downside, okay? When the keys are being changed, you will be losing your connectivity. We thought that was a crazy idea, that wouldn't work, but of course we tried it. And therefore we started working on that. We just wanted to replace the key with an OTP seed, and from there we made the change. So we had done the latched OTP, and we have introduced that, the OTP systems into latched, and we have tested that in a protocol that we made. It was a free service, which was another crazy thing from the innovation area, and I've been supporting it or trying to do it for many years. And at the end, I used this one because all the packets are free and limited. I wanted to use them as a transportation system so that I could implement a protocol on top of them. Well, we use BitGram, which is an internet that doesn't use the internet. It uses the SMS channel for you to connect to the servers so that you can send yourself a Gmail using an SMS through BitGram, or publishing something on your Facebook, because it encapsulates the message that you want to send through SMS, through a server with an endpoint with the listeners of SMS, and it also uses the token that you have configured to access to that service on the internet. Because the SMS was not encrypted, we created an encrypted system using a TOP. When you paired yourself first time, the two generates a OTP seed, and then it generates messages with that key, and the decryption is only possible if the message arrives in first 2 minutes. Okay, so we decided to try that out for our router, and I said, well, let's see what happens if we just use a TOTP. So it works very simply. So this is a first approach. When we have the router generating a random code that will show it to me through a QR code, and I will have that on the client side. Then the client will have that random code and the key that I set for my router, then a TOTP will be generated. The key is both configured on the router and the clients, and once that random value is shared, we create a way to generate the seeds and the encryption key resulting out of it. So, well, the time to renew is the type that we set, and for that we use a key which is derived from the TOTP. If we set it to every 60 seconds, that will be every 60 seconds, or every 2 minutes, or every day, as we choose. And what is most important about this is the possibility to synchronize it, to make it go in sync, and then it will be changed simultaneously both on the router side and on the client side. So this is the testing that we did. You see how this idea works. It says it is no time to change, no time to change, and then it connects itself, it logs on, and then this is the pin, that is to say the number of packets that are lost with this change. So you can see that depending on the hardware that you use, well, it will be about to change very soon. A few seconds it will change. So these are the number of packets, okay? So this is the pin, okay? Let us take a look at the change. Okay, so the key is changed. Let's see the pin, sorry. Exactly 3 packets have been lost. So this is what we have seen. Well, 3 packets may be good or bad, depending on the resilience or resistance of the protocol that that is on top of it. Okay, let us try it out with HTTP download. So we did exactly the same thing, but this time we developed FOCA. Okay, so you see that this browser for this number of packets will not have any problems during the time, well, the losing of packets, and because it worked, so let's try it in an actual router. So now we set up a tool, WILD WIFI. We just wanted to check this. So the environment is very simple. We just use the Movistar router. It is not the one of the latest. It is, well, it was just sitting around, and we decided to use it. We used an open WRT and a customized Lucy, and we added a latch instead of using WPA or WPA. So we use a web TOTP, and then we have the client for Android and for Windows. This is a simple code. So you connect through the router admin panel, and then you will have a QR code that we scan. It will be running after the scanning. Then you will get the TOTP seed, the pre-shared half key, then the name of the network and the time to renew. Once you have it, you are ready to download it. In the case of Windows, well, you don't scan the QR code and you have to change the key. Everything is put together in this video, but there is no, okay, do you have an HDMI adapter? So this coverage is not very good. And then we decided to set up a very simple environment. So I said this one connects to the internet. This one has a virtual machine that routes this thing to this other. This one connects to this one through this cable, and this one connects to this other one. Did you get it? Wi-Fi from here to here cable, virtual machine doing the routing, goes through the USB, through the iPhone, through the internet. Well, nothing can go wrong, isn't it? Okay, cable. Well, I have the machine here. This is the portal. Okay, it's DMI now. Well, it will be so quick just to play the video, isn't it? Okay, let's available port. Okay, can you see that? Okay, full screen. Okay, so extended view. Okay, mirror display. Okay, go for it. Okay, this is the system. I will enter the telephone number. See if it finds the device and connects to it. If everything goes fine, telephone number should show here. Okay, I have the app here, I have the panel here. Well, see what happens. Okay, why not? Okay, I will disconnect, I will connect again. Okay, select, yes, it's me. Accept. Okay, show the handset, okay, or the device for me. Okay, wonderful. Okay, so this is the viewing panel. Oh, we will scan the QR code that is here. Hope everything goes fine. So on the config panel for the Wi-Fi, we have the WPA2 TOTP. So this is thought for any system based on pre-shared key, despite whether it is useless or not, as it is the case through thanks to crack WPA2. So we have the secrets that it will be generated to create the TOTP or the seed, and then the PSHK makes sense. Okay, I will tell you more about it at the end of the presentation. Okay, we will be generating a secret. Okay, so we log in. So this goes as fast as it goes. Okay, as far as it can, fast as it can go. Okay, now I have to open the latch. I'm doing this on purpose so that you know that it comes with the latch. Okay, log in. Oh, it's very fast, isn't it? Wonderful speed. Okay, wireless now. Latch implementation will also be made available just in case you want to use it. So we go to wireless. Okay. So we see a Wi-Fi network, we edit it. So configuration, security. So we will generate a new secret. Save and apply, so that the final QR code is generated, and so that we scan it. Okay, go for it. Okay, then we go to the mobile app. I will scan it. I will do it from here. I will scan it from here, and then you will see it on the app. Basically, what you have on the app, well, this is an app that the Wi-Fi generates or manages the Wi-Fi Android client. This is a proof of concept. It has a countdown. It changes. Okay, it tells me the one that is working on. So it is synchronizing itself with the access points. Every time the countdown goes to 0, the key is changed and it is restarted. The underlying protocol remains the same. The only thing that we are doing is changing on top through the the key of the router, the configuration key of the router. It will have to disconnect itself from here to reset them both and to reconnect again. So I switch off, I change, I restart. That should be done with no root privileges and right now. So the key is generated through TOTP clients and then it will take me to the Wi-Fi. Okay, and to do the test, so hardware is really bad and connectivity is so and so. Okay, then we will open Firefox. So very poor coverage. Okay, so we download Foca from 11 paths, and actually, well, I set it to 60 seconds, okay, because I wanted it to go fast. This is the idea. I just don't want to waste time here, but this is the idea. So this is a 60-second video. Did you get it? Exactly the same process. Oh, wonderful music. Marlboro, I will mute it. Okay, basically, well, this is exactly the same thing. So, admin panel. Of course, latched. Are you clear that latch is integrated, latch is embedded? Okay, latch. Login, same option. We go to config, wireless. Okay, we'll skip that part. Okay, we have a QR code. Set and apply, scan it. Okay, same as before, we scan it. You need privilege to manage the Wi-Fi and the key, exactly the same as before, 60 seconds. It is making or negotiating. Okay, it changes the key, and in this case we download Kali Linux. Okay, and then the download starts. Okay, so everything about the password. So in an environment where you can change the key every 5 minutes, 7 minutes, we thought that it was really cool. And because it worked for us, we decided to go further and just say, what if instead of using a password, we use biometry? So that it's only about my Wi-Fi. That is to say that the key is changed every time I configure the TOTP. But to generate the seed for the TOPT key, I want to use my biometry so that no one else can do it instead of me unless they will replicate my biometric profile. Well, in 11 Path we have technology for hand biometry, so we published this paper to access to tokens. So imagine when you get an SMS from your bank, it gives you the option to sign it, and someone may go and say, well, I had the SMS stolen and they have hacked my SMS channel and they have used my token to sign the transaction. So therefore we worked in a way where you registered your voice and then TOTP was not given to you unless your voice was biometrically recognized. We did a large implementation. It is not public because it was a proof of concept. And then you got a number, you read that number, and those numbers helped recognize that it was you because of the biometric pattern, and then they showed you the signature token. So we use the biometry now to generate the TOTP seed and to ensure, well, that no one would replace us, okay, or spoof us. So we are considering, well, we have a patent for it and we are planning to make it available to mass public. Okay, so you have a router at home, you set or you plug in a screen and a microphone, so like the digital assistants, and then you have a screen, so you have everything that you need to play around with it. So we do an enrollment of the biometric data in the router, so either you use your face or your voice to make an enrollment in the router. That helps you generate the seed. The router stores that biometric value, generates a random value and shows it to the user through a QR code. So that is to say the router has everything it needed to generate the keys that we change depending on the time that we set at the TOTP algorithm, and then on the other side the customer only needs only to read the QR code, but the QR code doesn't have the biometric pattern because the biometric pattern is the customer. So the customer makes an enrollment of the biometric side, the router through the QR code gives whatever is missing, that is to say the random part that is needed to log in, and then when the router wants to log in to generate the seed, there is a request. If the client accesses to his biometric pattern, that is to say he faces up to the camera or talks to the device right away, for instance, okay, Aura, recognize me, or whatever instruction, then I already have the biometric pattern stored in my customer. Then I bring it to me, I call it, and I have the random, and I have everything that I need. So in order to show, to prove that it is me, and I have everything that I need, I just sent out a hello with an encrypted key. So hopefully you will see it soon somewhere around. So conclusions of this research, or this work. So we wanted to see what we could improve in the protocols based on pre-shared key. We wanted to see whether the solution could be improved. This is not for web, WPA, WPA2, but for any system which is based on password. So we just wanted to add top layer of security. So, which is the config with which that Wi-Fi is working, to know whether there is a higher or lower risk of being attacked, as we did in Mummy. So we can also detect the level of risk in real time, so knowing who are neighbors, what your neighbors are behaving, whether you are in the right neighborhood or not. We can also reduce the surface of exposure to rogue APs, as we've seen with SSID pinning, by location, by doing a neighboring analysis. And we can also, we did that through Seco Wi-Fi, and we can also improve security with MAC spoofing. So attacks to the key can be improved through an analysis of your key, telling you that about the level of security of your key, also using keys that change over shorter period of time, as we're seeing in Wild Wife, or using biometrics. So that is to say, creating a key which is only valid for you or to any other user which is authorized by you through your biometrics. So this is research work that we carried out over a long period of time aimed at improving things in terms of Wi-Fi and customers. So many of us have worked on these research projects, and now it is time to take any questions that you may have. Well, right, questions may come also from the other side, from the other room. It is too late, very late. And you hungry? Okay, are the questions here? Yes. Okay, there is a question over there. Good morning. Thank you for your awesome presentation. Very quickly, you told us about time to renewal, WILD Wi-Fi. Have you made tests about how you can play around with that stability? Well, thank you very much. That depends very, very much on the hardware and access points. So we were really risky here. We set it to 60 seconds with this device, which we connecting to the internet through the mobile phone. It worked. But in an ordinary environment, you can change it every second and it works well. Well, if there are many users, the environment changes. So we don't have any statistical analysis about the best configuration for that specific Wi-Fi, but this is very usable. This is, yes, very usable. So we have a question from the other room. Hello, Chema. I'd like to ask you a quick question. Have you thought about the possibility of starting two Wi-Fi network simultaneously overlapping the TOTP so that it jumps from one Wi-Fi to another and to overcome connectivity issues? Yes, we did it with Raspberry Pi, working in parallel. We thought about it. This is one of the things that we are considering, that we are playing around with. We want to do it. Yes, we thought about it. That's an idea that I believe could work well. However, well, for instance, imagine that you put it into production for many users, for many customers, therefore it becomes more complex. We would have different Wi-Fi's at different bands, but we tried it and it works. Yes, it is feasible, it is doable. So, well, my question is a bit more philosophical. I love the presentation, especially the last part of it. Okay, you told us about the patent and you have a serious intention to commercialize it. I love the system. But if you give me 9x9 of LEDs extracting the QR or a small screen of electronic ink, I just don't want an Alexa at home. Well, what about that? But it is your choice. You can do it in 1,000 different ways. For Windows, well, you can set it up for Windows, you can have it for Windows. So everything is boxed, okay? So we are at the very, very early stage. Okay, we have to go through the white men of user experience that will help us out with that. Okay, so I have, but I have a known rights, okay, to ask you a question. So those of us who have a routers at home, this is not related whatsoever to Telefonica. I'm not here on behalf of Telefonica. No, you as Chema Alonso. Would you have a firmware that can download so that I can flash it? We will publish the code by the time it will be stable. Yes, we will have images for some devices, okay? We will publish or disclose images. But rather than the tool, focus on the ideas. Recall the ideas. Well, the tools are spaghetti code and just proof of concept. Okay. Hello, Chema. Wonderful presentation. Thank you for it. I have a key question. So when you say that, well, biometrics, Wi-Fi only for yourself, you said that the TOPT password is generated, isn't it? So when the customer scans that, would that be only for that person or not? Would it be the same QR for a group of people at that specific point in time? Am I right? Well, there are several possibilities. So at this point in time, if you use a pre-shared key, you can only introduce a seed, set a seed to the Wi-Fi. we are still looking at the possible options, but you configure one and that's the one for that network. If you want another one for using the same biometric pattern, you can generate that seed, the very same seed, but the protocol is about a key that, and then the rest of the encryption keys are derived by it. So for the time being, has only been thought for one biometric pattern. So if we want to use it for more people, then we will have to change what is below the protocol. Well, I have pirated my if someone is in my mobile phone extracting information, the moment, well, me with my mobile phone, I am getting the QR. If the other person also gets the QR, we'll be able to log on to the network because we are sharing the QR. No. The patents, the QR only gives you part of the network. The other part of the network is your biometric data. The QR which is exchanged, it's a random value which is generated in the router, but it's only half of the password. The other half of the password is fed with your biometric data. So the question is good because I have the device under control, I can duplicate. Well, if you record my voice and intercept the signal, yes. Could you do that despite the MAC address? That is to say, calculating the QR applied to the formula. So this is a very interesting question. QR code doesn't have a MAC address. The jump of QR is via an image, okay? Via a photo. So apologies, but at what point? All right, thank you very much. Okay, we break for lunch now. Thank you.